I'm Anand Chaudhary. I'm a 6th grader in John F. Kennedy Middle School in Cupertino, California. Today, I am here to tell you about what the quadratic equation is. So, why don't we get started? The quadratic equation is any equation which takes form in y is equal to ax squared plus bx plus c, where a and b are coefficients and c is just a number. So, but this equation over here, it only stands true in one condition: if a is not equal to 0. If a is equal to 0, you will see that this will become bx plus c, and that is the equation for a linear equation. So we have to make sure a is not equal to 0 if this is going to be a quadratic. Well, we know that every single equation has their own unique graph. So what is its graph? Well, its graph is something called a parabola. So let's just label our axes over here. This is our x-axis or y-axis, the negative part of our y-axis, and the negative part of our x-axis. So the parabola is a graph that looks like this, where this graph, it cuts the roots, it cuts the x-axis, and it has the middle point. Well, what are these called? These are called roots. And what is this called? This can be referred to as the minima, or the vertex. This name, the minima, would only be true if it's actually the lowest point on the graph, which in this case it is. But you may be asking, is this the only type of parabola, or are there multiple kinds? Well, there are two kinds of parabolas, which are, so let's just label our axes again, x, y. It could also be the other way around. Does it have the same properties? Of course it does. It has roots which cut the x-axis. It has a vertex. So yeah, it has the exact same thing. Except what I see here is that this has a minimum point. Well, in this case, this vertex over here is not the minimum point. As we can see, it'll go all the way down here somewhere. But this will actually be referred to as not the minima, but the maxima. And the maxima is basically the maximum point of any graph. So, in what condition will this be like this? Well, a will have to be greater than 0 in order for it to be a ditch-looking parabola. So one way I remember this is if a is greater than 0, and remember a in this case is this coefficient of x squared. How I remember this is if a is greater than 0, the parabola kind of looks like a ditch or like a hole, and for this one, the a is going to have to be less than 0. And to me, this kind of looks like a hill. So that's one thing to know. Now, let's go on. So, how do we calculate these roots and the vertex? So let's start off with the roots. So the roots, as we saw, let's have one big parabola. X-axis, y-axis. So, as we discussed, the roots of a parabola are where it cuts the x-axis. So, how do we calculate them? That's a good question. There are many ways. There are some formulas, and let's start with the most known quadratic form called quadratic formula. The quadratic formula, let's write this down. The quadratic formula is actually a hard formula. It was a hard formula for me to remember, so this might take a while for you to remember as well, but let me just write it down for you. Minus b, this coefficient b over up here again, minus b plus or minus the square root of b squared minus 4ac divided by 2a. And actually this b squared minus 4ac part is one of the most important parts, because that actually b squared minus 4ac it is equal to this other like coefficient which you calculate using this, which is called d. This will help you for a lot of things. For example, if d is greater than 0, the roots will be real and distinct. Will be real and distinct. And let's see. What does this mean? What is real and distinct? You guys are probably confused. Real and distinct means the roots will probably be cutting the x-axis. It's real. So, what do you mean? If their roots like cut the x-axis? Well, not all parabolas have roots that actually cut through the x-axis and has like an extra part which like cuts down or cuts up, in this case up here. It has some, we'll go on to it later, but some roots, for example, let's go to the next one. It'll explain this to you a lot more. If d is equal to 0, the roots will be real as usual and same. What does that mean? You may be asking. So let me just draw like a small like x and y axis here. That means if the parabola has a vertex which is actually also its roots. See, as you can see, this is the vertex, but it's also the only root. It's the only one touching the x-axis. And you may be wondering, wow, this is really surprising. I thought it could only cut the x-axis. Well, no, there's actually one more thing to tell you. If d is less than 0, the roots are imaginary. Now, you may be guessing that that means there are no roots. And if you guess that, you are right. Because let me go on to this next page over here and show you what I mean by the roots are imaginary. So what I mean by the roots are imaginary is that if I draw this graph over here, that means if I were to draw a parabola, the parabola never cuts the x-axis. That also means that there are no roots. So that's what it means if it has imaginary roots. So now, how do you calculate this vertex I've been telling you about? This vertex, the one that's in the middle of this whole parabola. Well, it's not that complex of a formula, but you're gonna have to use that d I was telling you about, that new coefficient d. So let me just write the quadratic equation again. Y equals ax squared plus bx plus c. So the formula for finding this vertex over here, this vertex, is actually minus b divided by 2a, and this is like in parentheses. You have to write this like an ordered pair for like when you're trying to graph something. Minus b by 2a, and minus d, that d that I was telling you about, by 4a. Now, as you can see, these are all coefficients here. B, A, D is the one we're going to have to calculate. And remember,